And what we're looking at with relative risk is it's measuring a percent increase, percent decrease. So there's a couple different ways we can interpret this. We can interpret it as the proportion in group 1 is whatever your value for relative risk times the proportion in group 2. Because when we find that value, we're looking at relative risk. If we multiplied both sides times p hat 2, this shows that our sample proportion in group 1 is the relative risk times the proportion in group 2. So that's one way to interpret it. Or we can convert to a percent increase or decrease. When we look at this, we take our relative risk minus 1 times 100%. And that will give us either a percent increase if it's a positive value or a percent decrease if it's a negative value. And then when we interpret, we'll say that our proportion in group 1 is the relative risk minus 1 as a percentage, either higher if the value is positive or lower than the proportion in group 2. We can look at an example if that would be useful.
I think I understand actually now. Thank you.
Okay. Does anybody else have another question? Elijah, did you have a question?
Yeah, I'm just trying to figure out kind of the section I needed help with right now.
Okay. Hannah, what about you? Do you have any questions?
Not really. I feel like I just need more practice.
Okay. And I just got a worksheet posted that we can look at some questions off of there, but I'm happy to answer some other questions first if you guys have any.
No, I think I'm okay, actually. If I could just do some practice problems, that'd be helpful.
Okay. Well, let me just give a little bit more notes in terms of what we're looking at with these two values. We look at relative risk, and then we're also looking at the difference in proportions. So kind of, we'd already talked about last week, these two summary measures, the difference in proportions and then the relative risk. And today we looked at, well, this week we looked at simulation testing. Of both the difference in proportions and then also relative risk. So with both, we're testing, so our null hypothesis assumes there is no association. I'm going to say true association because we need to talk about our parameter. No true association between the explanatory variable and the response. So for a difference in proportions, our null is that the proportions are equal, or you could say that the difference is equal to 0. Either way is appropriate. Oops. Can't make zeros very well. And then for the alternative, with any alternative, we always look at the relationship between our parameters. And it's either greater than, not equal to, or less than, dependent on our research question. So we've looked at a two-sided test when what we looked at in 5.2 is a right-sided test that we were trying to show that yawning is contagious. We could look at a two-sided test where we're just trying to see, is there some sort of difference? Any questions on simulation testing for difference in proportions?
We use the historical variables.
Sorry, could you repeat that?
Do you only use these for 2 categorical variables?
Yes, this is only for testing of 2 categorical variables where both are explanatory and the response are categorical.
Okay, cool.
So then we can also test relative risk. And this also tests that there's no association. But now, because we're looking at the ratio of proportions, we're assuming that the relative risk is equal to 1. Because if pi 1 and pi 2 are equal, then the ratio would be equal to 1. Our alternative, again, can be right-sided, two-sided, or left-sided, dependent on that research question. And we just use the appropriate statistic to find our p-value. And we'll kind of look at those simulations once we start looking at that worksheet. I want to talk briefly about confidence intervals as well for a difference in proportions, and then we'll start working through kind of an example to look at that. Any questions on testing relative risk? Okay, to find our confidence interval, so this is when we're estimating the parameter. We always use our statistic plus or minus the margin of error. So far in class, we've only focused on the 2SD method. So our statistic is the difference in proportions. Whoops, too many. So p hat 1 minus p hat 2 plus or minus 2. We use 2 as the multiplier in our margin of error when using the 2SD method. And then multiplied times the standard deviation of the null. One thing that's a little different when we interpret the confidence interval, we still want to use our level of confidence, like we're 95% confident or 99% confident. We still have a statement about our parameter of interest, because we're always confident the parameter is within the interval. We'll have our calculated interval. And then we'll also talk about the order of subtraction. So this is kind of the new addition when we're talking about when we're talking about confidence or differences, when we're talking about two variables, we need to think about that order of subtraction. So which group has the higher proportion? And we'll work through an example on how to find that. Any questions on these notes?
No, thank you.
Okay. So everybody got this down? Is it all right if I stop sharing this screen?
Yeah, I'm done.
All right, so I do have this worksheet that I posted in the Google Drive folder. I just posted a little bit ago, but it is up there if you want to pull that open. So this is looking at two categorical variables, and we have a two-way table there. It says a survey asked people how often they exceed speed limits. The data are then categorized into the following two-way table of counts. So we have age group, either under 30 or over 30. And our response variable is whether or not they always or not always exceed the speed limit. And we're looking for an association between age and how often they exceed speed limits. All right, so thinking about this study, what would be the explanatory variable in this study? What two groups are we going to compare?
Over 30 and under 30.
Okay, so whether a person is under or over 30. And obviously the way this is set up, this is a categorical variable because we're categorizing into under or over 30. The rows or these column headers are always going to be or represent the explanatory variable for stat 216, and this is going to be our response. So our response is whether a person always or not always exceeds the speed limit. We're going to consider group one. We're going to say that group one is the under 30, and group two is our over 30. So if we're finding the conditional proportion of people over 30 that always exceed the speed limit, how are we going to calculate that value?
Is it 40 over 210?
Yep, 40 over 210. This is going to be p hat 2 because the over 30 is our group 2, and that proportion is 0.19. So now we're looking under 30, so that's going to be our p hat 1. How would we find that value?
$90 over 190.
90 over 190, because now we're focusing on the under 30, and this gives us 0.474 for p hat 1. So to find relative risk, we're looking at that ratio of the proportions. So we're going to take the 0.191, or sorry, I'm going to take the 0.27 or 474, which is our p hat 1 divided by p hat 2, and that gives us a relative risk of 2.493. Questions on how we found that? If we wanted to interpret as a percent increase, decrease, we have to do a conversion. So we're going to take relative risk minus 1 times 100. So 2.493 minus 1 times 100% gives me 149.3%. So now we're going to talk about the ratio, or how the proportion in group 1 is this percent higher than the proportion in group 2. So the proportion of people under 30, because we're talking about group 1, who always speed, is 149.3% higher, because it's a positive percentage, than the proportion of people over 30 who always speed. Questions on that interpretation? Okay, how would we find the conditional proportion of people, the difference in conditional proportion? So we're looking at p hat 1 minus p hat 2. How do we find that value?
Point 474 minus 0.19.
Okay.
Or actually, I might have that backwards.
Nope, you had it right, because our p hat 1 is the under 30, so we're taking under 30 minus over 30. Okay, and that's our p hat 1 notation that we use for the difference in proportions. To interpret this value, we're going to talk about how much higher. So if we think about p hat 1 minus p hat 2 equal to 0.284, if we add p hat 2 to both sides, we can see that the proportion in group 1 is equal to the difference plus p hat 2. So p hat 1 is 0.284 higher than p hat 2. So the proportion of people under 30 who always speed is 0.284 higher than the proportion under or over 30 who always speed. Do you see how that interpretation differs from what we saw when we interpreted relative risk? Any questions? Okay. So does there appear to be an association between the two variables? What do you guys think? Is there an association between these variables?
Yes.
Okay. Yeah, we can see that our relative risk is definitely greater than 1 and our difference in proportions is greater than 0. So yes, there's an association. The relative risk is greater than 1 and the difference in proportions is greater than 0. So we can definitely see that there's an association. We don't know if it's significant or not, because it could be significant, but we'd have to find our p-value to be able to answer that question. So when we're testing for the difference in proportions, we're always assuming that there is no difference or there is no association. So in terms specifically of differences in proportions, we can say that there is no difference. In true proportion of people who always speed for those under 30 and those over 30. And we are looking at under minus over. For our alternative, we've got to think about our research question. So if we look back up, it just says that they're testing for an association back in question, the very beginning, the prompt for the question. So if we're just testing for an association, what direction would that indicate for our alternative? Two-sided, right or left?
Would it be two-sided?
It'd be two-sided. We're just testing to see, is there a difference? So our alternative would be there is a difference. And we are saying that same thing. So there is a difference in true proportion. Of people who always speed. For those under 30 and those over 30. Again, our order of subtraction is under minus over. Questions on those hypotheses? Okay, when we think about our simulation, we'd always start with our sample size for our number of cards. So if we go back and look at our two-way table, we can see that there were 400 people in this study. So we're going to start with 400 cards and we label them with either always or not always, because we're going to label them with the response. So we're going to have 400 cards. We're going to label them with always. So we're going to have 130 labeled with always and 270 with not always. So this represents our response variable. So if you look at that two-way table again, you can see that that's this 130 and the 270. And next we're going to put them into two piles representing the explanatory. So 190 and 210. Because remember, when we're creating the null distribution, it doesn't matter which group our cards end up into, because we're assuming there is no association. So we'd shuffle together. And put in 2 piles. $190, and that represents under 30. And then 210 to represent over 30. Because for this distribution, we're assuming, or we're plotting the difference in proportions, we would plot the difference in proportion of people who always speed for under 30 minus over 30. So I'm going to switch over to the applet, and we'll put the data into the applet just so you can see kind of how the applet is set up. So we're using this multiple proportions applet and the 2x2 table for our successes. We'll have the 90 because we're looking at 90 people who always speed in the under 30 and 100 that don't. And then 40 that always speed in the over 30 and 170 that don't. And there we can see that observed difference of 0.28. I think I had 4, just with rounding, we get slightly different values. And we're looking at that difference in proportions. And if we create 1,000 different simulations, why does it make sense that my center of my null distribution is close to 0? Why would that make sense to have that null distribution close to 0?
Because we said there was no association.
Right, we're assuming there's no association. All right, so how do I find the p-value for the difference in proportions for this study?
You changed the greater than to beyond, and
Okay.
then you put in your statistic.
Okay, and what's the statistic for this?
Is it 0.283?
Yep, it's this observed difference right there. So I'm going to put in 0.283. And we get a very small p-value, so less than 1 out of 1,000. What if we wanted to test relative risk? I could change this to relative risk. There it's showing me that relative risk value that we calculated earlier. What would I do with that relative risk value to be able to find this p-value for relative risk? Now what's that?
Would you put it in count samples, or is that a different number?
No, yeah, we're gonna put the 0.2487 and count my samples beyond the relative risk value of 2.487. And again, we're getting a p-value that's really small. Now this distribution is centered close to 1 because we're assuming there is no association. So our relative risk would be equal to 1. Questions on the applet? Okay, we'll go look back at that screen again, or at that worksheet. Okay. So here we're putting in the value of our difference in proportion. So the point, well, this would be the beyond 0.283 or 0.284 to get our count. And we saw a very small p-value, less than 1 out of 1,000. So what would our decision be at a significance level of 1%? So that tells me my significance level is 0.01. Is our p-value less than or greater than 0.01?
Less than.
Okay, so our decision is to reject the null because that p-value is less than the significance level. Do we have strong evidence or weak evidence, moderate? How much evidence do we have?
Strong.
Yep, we have a really small p-value. So when we write a conclusion, we write it in terms of the alternative. So there's very strong evidence that there is a difference in true proportion of people who always speed. For those over 30 or under 30 compared to over. Because we always write conclusions about our alternative hypothesis. The p-value interpretation is going to be very similar to what we've always done as a p-value interpretation, talking about the probability of our observed result, or more extreme, if the null is true. So in less than 0.001 simulated samples, we would observe a difference in sample proportions I think my of 0.284 or more extreme. If there is no association between whether or not always speed and age group. We'll do under 30 minus over 30. So if our null is true. The more extreme is referencing that it's a two-sided test. Questions on the interpretation? Okay, so for each of the following values, would you expect the value to be below, above, or contained in a 90% confidence interval? So if we created a confidence interval for our parameter, the difference in proportions, would 0 be in our confidence interval? How can you tell based on your p-value?
Zero wouldn't be in it because we have strong evidence against the null, and if zero was in it, then it would be saying that there's a chance that there's no association.
Right, so this entire interval will be above because we were doing the order of subtraction of under minus over, and we had a positive value for that. And she's right, we would have evidence. So based on the p-value, we have strong evidence against the null. So 0 would not be in our interval. How about 0.284? Would that be in the interval? So remember, this is the difference in proportions. So it's going to be in there because it's the sample statistic. And the sample statistic is the center of the interval. So to find this confidence interval, we always look at our statistic plus or minus the 2SD, 2 times standard deviation of the null. So we still have that 0.284, which was our sample statistic, plus or minus 2. And what's the value of the standard deviation of the null?
0.0, right?
Yep, 0.048 comes from right there, from our null distribution. So we put the 0.048. So that gives me 0.188 to 0.380 for my confidence interval. So when we interpret this, we want to talk about how confident we are. We want to talk about our interval that we have, our parameter, and then that order of subtraction. So if we talked about this relationship between pi 1 and pi 2, because our order of subtraction was pi 1 minus pi 2, and we have positive numbers, that tells me that my proportion, the true proportion in group 1 is higher than the true proportion in group 2. So we'd say we are 95% confident. The true proportion of people under 30 who always speed is 0. So that should be is 0.188 to 0.380 higher, because they're both positive, than the true proportion of people over 30 who always speed. That making sense on how we put that into context and talking about that order of subtraction? questions over this worksheet or anything about this study, this section 5.1 and 5.2? Did you guys get everything written down off this page?
Yeah, I'm good. Thank you.
Okay, do you guys have any more questions?
No, thank you.
Yeah, no problem. Talk to you later.
Yeah.